stood for Little Green Men. It seemed at first less incredible to think that intelligent beings elsewhere in the universe were trying to get in touch with us than to imagine that a star could produce this jazzy rhythm. The pulsars are just the latest in an extraordinary series of discoveries made in the past few years. All over the world, astronomers have spotted events of breathtaking violence, scarcely explicable in the known forces of nature. They are also on the brink of establishing for the first time the history and fate of the universe we live in. That's why we've invited you tonight to come with us around the world. We shall visit the great observatory.
Doing nothing. And all I saw was something like silver coming down, and I said, what must that be? And everybody's crowding it. I must go crowd too. And then I went and I started crowding, and everybody, then more people came and more. And then I said, hey, I can't see anymore. Come on, somebody, I'm short. Come on. And then I went to the front and I started seeing more of them, and then I just ran away.
The day before the spaceship came, my friends and I were sitting in the playground, and one of my friends, her name Emily, she looked up into the sky and she said, oh, there's a UFO. She said, and I looked at it and she said, no, just kidding, it's an aeroplane. And we looked up and I thought to myself, that can't be an airplane because it was very shiny. It looked kind of like a cigarette, you know. It was a long thing and then on the end it was all shiny. So I said, maybe it is a UFO. So we were all kind of like getting scared now. And then the day that it happened, then we started thinking, yeah, there must have been a UFO in the sky. Because my brother also saw it, but he's left the school now.
Mm-hmm. It was sort of like a round shape, sort of like a plate, sort of like two plates that were sort of like on top of each other. Then there was sort of like the hole, the hatch for it, and there was sort of like in between two trees. But you couldn't see that clearly, and it was just silver all over. And I didn't see any men or something like that.
You saw one UFO that's surrounded by little ones?
Yeah, one big one. One spaceship.
Yeah?
Little ones around.
Yeah, let me see. Let me see your drawing. One big one.
One big ship and then small ones surrounding it with they were lights.
Yeah.
Surrounding the ship.
Like Sean's, huh? This is Sean's drawing.
Yes, yeah, basically.
Yeah. And okay, one landed, the big one landed, and the two aliens came out.
Yes.
And what happened with the little ones?
The little ones, they were just flowing around
In the air, they didn't
touch the ground.
Next to
And
And that, these made the silver lights?
Yeah.
they were making different color lights, like
Yeah,
green,
like they'd
red,
flash to green, then they'd go to blue,
and then
red,
purple.
green. Yeah, purple and red.
But it was like it was going like each one to each one, but quickly.
like they'll go there and then it'll vanish, and then it'll go there and vanish, and then vanish.
Oh,
But
really?
going quickly.
Like as if it was one ship moving
Yeah.
places.
And through this vast have with us Carl Sagan from Cornell University.
Our sun is a star. It seems large because it's so close, but for all that, it's a humdrum and quite ordinary star. We've modeled the sun and the nearby stars. Here, this star that's blinking is our sun. Near it are the neighboring stars in space. Because of our vantage point near the sun, we're able to recognize the familiar constellations of the night sky. To the north, we can see the Big Dipper, pointing towards the pole star. Near the Milky Way, we can see the familiar winter constellation Orion. If you live in the southern hemisphere, you'll recognize the Southern Cross. Let's take a stroll among the stars. Let's amble north. As we do so, let's keep an eye on the Big Dipper. Notice how its shape seems to change as our perspective changes. The reason is that the Big Dipper is composed of stars, some of them intrinsically bright, but rather far away, some dimmer, but closer in. The constellations that seem to be points of light painted on the vault of the heavens are really composed of stars at a variety of distances. And if there are creatures that live on planets of other stars, they will see different constellations in the night skies than we do. Well, we reached a star which astronomers call Gamma Cephei. It's so far from the sun that it takes light some 50 years to travel from the one to the other. The earliest signals of our technical civilization on the Earth are only just now reaching Gamma Cephei. These signals are the earliest radio broadcasts, perhaps an aria of Enrico Caruso, but we do not know if there's anyone here to listen. Let's take a look back the way we've come. Let's try to see if we can recognize where we've come from. Which of these stars is the sun? The sun is such an insignificant star that we can't make out which of all these stars it is. In fact, the only way we can do that is to ask it to blink for us. Blink, sun. There it is. We can now amble back towards home. As we do so, we can recall that these points of light in the sky, every one of them is as mighty a star as our sun. Let's head home to our familiar solar system. As we do so, we can recognize the planets accompanying the sun. Looming up is the giant planet Jupiter, a gassy planet very different from the rocky and metallic Earth. As we move inwards from Jupiter towards the sun, we can make out the red planet Mars, a possible abode of life, the target of 2 American space vehicles now on their way to explore Mars. If we continue further inwards towards the sun, rapidly passing by our home planet, we reach Venus, a cloud-covered planet with a searing hot surface. At the present time, there are 2 space vehicles launched by the Soviet Union which are headed towards Venus, perhaps to land there. Let's now return to our comfortable and cozy home planet, the Earth, with its tiny moon which circles it.
This is the year of Apollo, when men may first set foot on the moon. It's an extraordinary enterprise, a first step into the universe. But distances in the universe are so vast that they're often reckoned by the time light takes to cover them, at 186,000 miles a second. The moon is a little more than 1 light second away, and light from the sun takes 8 minutes to get here.
In our little excursion among the stars, we traveled a total equivalent distance of perhaps 100 light years. Later on in this program, we'll be concerned with immensely greater distances of billions of light years. Compare that with the tiny 1 1/3 light seconds between the Earth and the moon. Astronomers worry about 2 very large questions. How does the universe work, and where did it come from? In this program, we consider both these questions on the nature and the origin of the universe. The first question is an attempt at understanding what we see in the sky in terms of known natural laws. Why does the sun shine? How do stars evolve? What's the explanation for these extraordinary cosmic explosions which astronomers are detecting with appalling regularity? The second question is an even deeper one. Is it possible that the universe was made instantaneously from nothing at some remote epoch in the past? This is the view taught by Babylonian astronomers, and it's familiar to us from Genesis 1:1. Its modern astronomical version is called the Big Bang Theory. Or is it possible that the universe had no beginning, that it's infinitely old, as some Oriental religions teach? One modern astronomical version of this theory is called the steady state.
Of all the planets in the solar system, Earth and Mars, the third and fourth planets from the Sun, are the most similar. But despite the similarities, Mars is essentially like no other planet. It is a unique world. It was an elusive and baffling planet to astronomers for hundreds of years. Through early telescopes, it appeared to be a small red sphere, later estimated to be about half the size of Earth. One of the earliest known representations of the planet, drawn in 1659, indicated markings on the surface, and by the movement of these dark patches across the disk, it was shown that Mars rotated on its axis in a period only a little longer than Earth's, about 24½ hours. It was observed, too, that the tilt of its axis, like the Earth's, exposes its polar regions alternately to the sunlight. Thus, each hemisphere has a summer and winter period. And since Mars orbits the Sun in 687 Earth days, one Martian year and each of its seasons is almost twice as long as Earth's. Later mappings of the planet displayed light and dark regions identified erroneously as continents and oceans. The land masses red as the sandstone districts on Earth, the water a greenish blue. In 1877, an Italian astronomer, Giovanni Schiaparelli, discovered what he called canali, or channels, resembling, he said, the finest threads of a spider's web drawn across the disk. In America, Percival Lowell founded an observatory to study these Martian features. Massive irrigation systems, he called them, designed to carry water from the melting ice caps to the major centers of a dying civilization. Science fiction writers populated the cities with terrible creatures of heroic size, with skills beyond Earthman's dreams. In the 1960s, 3 Mariner spacecraft flew by Mars and photographed about 10% of the surface. Gone were the canals, gone were the cities, gone the brilliant and sinister Martians. The photographs revealed a cratered landscape much like the moon, waterless and apparently hostile to life. But in 1971, the Mariner 9 spacecraft orbited Mars and transmitted more than 7,000 photographs of the planet to Earth. The extensive mapping revealed a new and unexpected world. The southern hemisphere, seen by earlier spacecraft, flattened and gouged by the impact of meteorites. The northern hemisphere, a vast plain with few craters, and rising from the plain, a great dome called Tharsis, topped by giant volcanoes. The plateau that joins the two hemispheres is cut by a vast and deep canyon, and by channels with the characteristic patterns of stream beds on Earth. Some of the channels suggested that water may once have flowed on Mars, and thus life might have evolved and possibly adapted to Mars' changing conditions. And then in 1975, 2 Viking spacecraft were launched, each of which was programmed to land a robot on the Martian surface. One of its principal objectives was to test for the presence or absence of living organisms. A communication system linked the spacecraft to the Mission Control and Computing Center in Pasadena, California. On June 19, 1976, the first Viking arrived in the vicinity of Mars after a year-long journey of more than 400 million miles. Once in orbit, its cameras were turned to a detailed examination of the landing area. Imaging teams on Earth scanned some 800 photographs covering a territory about the size of Texas. The chosen landing site was a flat expanse with a few impact craters, one of the lowest regions on the surface. On July 20th, 1976, flight controllers ordered the lander to separate from the orbiter.
5, 4, 3, 2, 1, separation. Descent sequencing, we're at mission event word 0, and we have DL separation.
Because of Mars' great distance from Earth, the signal traveling at the speed of light, 186,000 miles per second, took 19 minutes to reach the spacecraft. This necessitated a completely automated system on board for carrying out the landing maneuver. During the lander's descent, its instruments analyzed the properties of the thin Martian atmosphere.
9,000 feet coming up on quarter bar.
Good roll attitude hold.
Be close to quarter bar. Firm quarter bar. Two loops and a high. Got it. We have quarter bar. Lander confirmed parachute deploy. Recon 1, TM2.
Do I have sync?
UHF minus 105.
Format 3 is in sync.
All right. Format 3 in sync. Leg deploy. 4,800 feet, 177 feet per second.
Confirm roll maneuver.
Parachute separation. Roger. Minus 105.
23 G.
2,600 feet, 188 feet per second.
2,600 feet. 2,600 feet.
366 feet.
73 feet per second.
ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs.
Feet per second.
Touchdown, Win. Fantastic. Copy that. 16 kilobits confirmed. Yes, we have a touchdown time of 12 hours, 12 minutes, 07.1 seconds.
Job very well done. Outstanding, great, navigation, perfect. I'm assuming that we must be sitting right on the X. So that's the smooth area. So everybody just did fabulous and couldn't be more pleased. Thank you.
25 seconds after landing, one of the two cameras was initiated and scanned the first picture of the Martian surface.
About a half an hour later, when it started to come back from the orbiter, and we got the first 7 lines on the TV monitors, you could see gray and white light levels, and we knew there was something there. Look at the beautiful rock. Fantastic. And all of a sudden, we were looking at the surface of Mars, and it was clear, it wasn't dusty, it was sharp. And when we got to the end of that first picture, with the dust and small pebbles in the footpad, it was just, it was really a miracle.
In an instant, the picture was wiped off the TV monitors, and behind it came the filling in of the second picture, a long panoramic view that covers 300 degrees and extends from the lander to the horizon. It disclosed a sector of the basin called Chrysi Planitia, covered with sand or dust and littered with rocks. The following day, Viking sent back the first color picture. A fine dust, red or yellow-brown, covers the ground. The sky is a light tint of the same color due to the particles of dust suspended in the air. 45 days after these historic events, Viking 2 landed in an area 4,600 miles northwest of Viking 1's landing site. A vast plain, littered too with rocks resembling those on Earth, produced by volcanic processes or by meteorite impact. While the landers conducted experiments on the surface, the orbiters swinging around the planet measured variations in moisture and temperature and took high-resolution photographs of the Martian terrain. Four and a half billion years ago, the planets were formed from the gas and dust of the solar nebula. In the formation of a planet, heat is released and remains embedded in the growing mass. Because the heat can't escape as rapidly as the mass is growing, a point is reached eventually where the interior melts. On Mars, the heavier material sank toward the center, and the lighter material rose to form a crust at the surface. And this crust contained ice and other condensates. A later stage may have occurred where molten rock intruded into the crust and melted the ice, causing a slurry of water and rock and dust to flow across the surface. Some observers believe that such a process may have been the cause of the major channels which we see on the surface of Mars today. But others believe that in Mars' first billion years, the atmosphere may have been warm and dense enough for rain to fall and for rivers to flow. Gradually, the original thick, wet, and warm blanket of the atmosphere evolved into the thin, dry carbon dioxide atmosphere we find there today. Because of Mars' low atmospheric pressure and low temperatures, water can't exist in liquid form. It must either freeze or evaporate. But while there are no oceans or rivers on Mars, there is more water in total than anyone had expected. The residual polar cap in the north, which remains after the hottest part of the northern summer, is water ice mixed with dust. And the measurements of the seasonal behavior of water vapor over the planet suggest that there is a vast reservoir of ice beneath the surface, so that one can think of the residual polar cap as the tip of an iceberg protruding from a sea of rock. At lower latitudes, the water vapor condenses to form clouds that ride high in the atmosphere or swirl around the slopes of Martian volcanoes. And further south, in the canyons and valleys, there is frequently an ice haze seen to form and evaporate in the early hours of the morning as the sun warms the atmosphere. On Earth, the ocean's heat and moisture and the heat and air currents over land masses interact to produce complex weather patterns. On Mars, because of the absence of large bodies of water and of massive cloud covers, the weather doesn't vary much from day to day. Like a remote weather station on Earth, Viking's meteorology instrument measures Mars' atmospheric pressure, temperature, wind speed, and wind direction. Temperatures range from minus 122 degrees Fahrenheit just after dawn to minus 22 degrees in the mid-afternoon. Light winds from the east in the late afternoon change to light winds from the southwest after midnight. Maximum wind speed is 15 miles per hour. But in the early summer, the heating of dust particles in the air generates violent dust storms in the low regions of the planet. Driven by winds that reach 150 miles an hour, they may blanket the entire planet in a few days.
In order to understand the geology and physics of wind-blown particles on Mars, we're conducting a series of experiments using this enormous space environment chamber here at NASA's Ames Research Center. We've placed an open circuit wind tunnel in this chamber, and we're able to operate at atmospheric surface pressures comparable to those on Mars. In this particular series of experiments, we have placed a crater model in the tunnel floor, and we want to determine the zones of erosion and deposition around the crater. In this particular case, we're going to let the wind blow across the crater and see what those zones of erosion and deposition are like.
The light and dark streaks associated with craters are the most common features on the surface of Mars related to wind. The light streaks are deposits of fallout from the global dust storms. The dark streaks are regions from which a thin layer of light material has been removed revealing a darker underlying surface. These streaks serve as wind markers. Their patterns define the wind flow. To the geologist, the features seen in the tens of thousands of photographs transmitted by Viking are the visible signs of the enormous forces and processes that have shaped the surface of Mars. The excavation of large basins and craters by the impact of meteorites and asteroids. The raising of mountains by the action of volcanoes. The faulting and subsidence of the crust as the planet expanded. And the cutting of channels by water, or abrasive particles driven by winds over a period of tens of millions of years. The key to the age and sequence of these features is found in the number and condition of craters. Those areas with fewest craters are assumed to be the youngest. Here, a fresh crater overlies an ancient eroded one. Here, the rim of a crater is eroded by water or wind. And here, adjacent to a fresh crater, is one of a cluster of crater rings, craters that have been buried to varying depths. Over millions of years, the repeated flows of lava built the volcanic mountains of Mars. 12 are larger than any on Earth. The largest, Olympus Mons, rises 3 times higher than Mount Everest and is broad enough to cover the whole chain of volcanoes that form the Hawaiian Islands. The great gash that cuts through Mars' equatorial zone is Valles Marineris, a mighty canyon system that extends over an area more than 3,000 miles long and up to 400 miles wide, and drops 4 miles below the flat cratered surface of the plateau. Canyon walls are gullied, dissected by tributary canyons, or scarred by catastrophic landslides, leaving steep cliffs and great fractured surfaces. Extending for 30 miles on the canyon floor is a field of sand dunes, suggesting that some of the debris produced by the collapse of the canyon walls was removed by wind. These ancient channels that resemble dry riverbeds on Earth could have been formed by primeval rainstorms. But the vast channel systems that start in areas of collapsed terrain, with broad streamlines extending hundreds of miles across the lowlands, and teardrop-shaped islands soaring to thousands of feet above the channel bed, testify to a process without any parallel on Earth. Viking also photographed the 2 cratered moons of Mars, Phobos, the inner moon, marked by striations which, on closer view, resolve into grooves several miles long, and Deimos, the smaller outer moon. Viking, traveling at 3,800 miles an hour and passing only 30 miles away, could observe boulders on the moon's surface, some as large as 100 feet across. The geologic record of the planet suggests that Mars, like the Earth, has experienced periodic changes of climate. The best evidence of this is seen in the strange spiral patterns of Mars' polar regions. The dark bands are scarps or cliffs of bare ground within the North Polar ice cap. On each scarp are numerous small terraces eroded from layered rocks. This is a model of layered terrain, an area about 40 miles across. It is believed that the large scarps and the small terraces represent 2 different cycles of climatic change which occur simultaneously. Because of Mars' oscillation in its orbit about the sun, the polar regions are alternately warm and cold for periods of tens of thousands to millions of years. During the cold period, mixtures of dust and ice were deposited in a series of near horizontal layers, obscuring the underlying topography. Then a period of warmer climate followed, and erosion set in, cutting deep valleys into the icy mass of the polar caps. After the erosion cycle, new layers were laid down, and another episode of erosion followed. This oblique truncating of one set of terraces by another indicates that the climate turns on and off, the first geological evidence for cyclical climatic change on a planet other than the Earth. The speculations about changes in the atmosphere and climate were closely related to the notion that life in some form might exist on Mars. On Earth, life developed several billion years ago, at a time when the overall properties of Mars and the Earth were very similar.
Now, over the ensuing billions of years, Mars and the Earth evolved separately. However, Mars today still has chemicals on its surface, an atmosphere, temperatures and pressures within which we believe life can exist. The Viking lander was equipped with 3 life detection experiments designed to test for chemical changes caused by life processes that are familiar to us on Earth. On Earth, all living organisms interact with the environment through a process called metabolism.
Animals, for example, take oxygen from the environment and use it to combust food, thereby obtaining energy. At the same time, they release carbon dioxide and other waste products into the environment. Green plants and some microorganisms do the reverse in the process of photosynthesis. They remove carbon dioxide from the environment, and using sunlight as the energy source, they convert the carbon dioxide into organic matter and release oxygen into the environment.
If the experiments on Mars indicated that similar processes were occurring, then we would presume the possible existence of organisms on that planet. Well, our results on Mars in certain experiments gave us data that seemed to mimic the metabolism of living organisms. However, careful analysis of that data indicates that it is probably the result of chemical rather than biological processes.
On Earth, all biological systems are based on organic chemistry, and it was believed that life on Mars would also be based on organic compounds. The notion was strengthened when experiments on Earth demonstrated that organic materials can be formed under simulated Martian conditions.
We used finely powdered minerals like those expected on the Martian surface. Then we added traces of water vapor and radioactive carbon monoxide at low pressure. To simulate Martian sunlight, we irradiated the mixture with light from a xenon arc lamp. When we heated the sample and captured the gases that were formed, our radiation counter showed that the carbon monoxide and water had been converted to organic compounds.
But Viking's instruments failed to detect organic compounds of any kind. That fact, in the opinion of some observers, has increased the odds against the existence of living organisms on Mars.
If we were able to do 1,000 experiments, different experiments on Mars, and to do these in a wide variety of places on Mars, in the canyons, on the polar caps, in some deep areas of the surface, and if in all of these experiments we got negative results, then the answer to the question, is there life on Mars, would almost certainly be no. But on the basis of just a few experiments, done at only 2 sites, very bland sites on the planet, I think it would be unscientific for us to come to that conclusion. All we can really say, for sure, is that we have run across some very interesting chemistry, a kind of chemistry that we do not see in surface samples from the Earth or surface samples from the Moon, and that's about where we are at the moment. Today, in laboratories across the nation, scientists are trying to simulate the results that we obtained on Mars. Some of the scientists are concentrating on irradiation experiments to see whether solar energy acting on Mars could have produced chemicals to account for the results. Other experiments are assuming that these chemicals were there and are testing one or another of these chemicals to see whether they can account for the results that were obtained.
The question of life on Mars is only one of the inexhaustible number of questions for which we continue to seek answers in space. Questions about the origin and evolution of the solar system, of our own planet, and our own species. The search for answers is a goal of planetary exploration, and the journeys of our spacecraft to the near and far reaches of the solar system are beginning to provide some of the answers.
will now recognize Mr. Elizondo for his opening statement.
Greetings, Chairwoman Mace, Chairman Grothman, Ranking Members Connolly and Garcia, and members of the committee. It is my honor and privilege to testify before you on the issue of unidentified anomalous phenomenon, formerly known as UFOs. On behalf of our brave men and women in uniform and across the intelligence community, as well as my fellow Americans who have awaited this day, thank you for your leadership on this important matter. Let me be clear. UAP are real. Advanced technologies not made by our government or any other government are monitoring sensitive military installations around the globe. Furthermore, the U.S. is in possession of UAP technologies, as are some of our adversaries. I believe we are in the midst of a multi-decade secretive arms race, one funded by misallocated taxpayer dollars and hidden from our elected representatives and oversight bodies. For many years, I was entrusted with protecting some of our nation's most sensitive programs. In my last position, I managed a special access program on behalf of the White House and the National Security Council. As such, I appreciate the need to protect certain sensitive intelligence and military information. I consider my oath to protect secrets as sacred, and I will always put the safety of the American people first. With that said, I also understand the consequences of excessive secrecy and stovepiping. Nowhere was this more apparent than in the aftermath of 9/11, which many of us remember all too well. I believe that America's greatness depends on three elements. A watchful Congress, B, a responsive executive branch, and C, an informed public. Over the last decade and a half, I learned that certain UAP programs were and are operating without any of these elements. Although much of my government work on the UAP subject still remains classified, excessive secrecy has led to grave misdeeds against loyal civil servants, military personnel, and the public, all to hide the fact that we are not alone in the cosmos. A small cadre within our own government involved in the UAP topic has created a culture of suppression and intimidation that I've personally been victim to, along with many of my former colleagues. This includes unwarranted criminal investigations, harassment, and efforts to destroy one's credibility. Most Americans would be shocked to learn that the Pentagon's very own Public Affairs Office openly employs a professional psychological operations officer as the singular point of contact for any UAP-related inquiries from citizens and the media. This is unacceptable. Many of my former colleagues and I have provided classified testimony to both the Department of Defense and the Intelligence Community Inspector General, and many of us have subsequently been targeted by this cabal with threats to our careers, our security clearances, and even our lives. This is not hyperbole, but a genuine fact, and this is wrong. To fix these problems, I propose three principal actions. First, Congress and the President should create a single point of contact responsible for a whole-of-government approach to the UAP issue. Currently, the White House, CIA, NASA, the Pentagon, Department of Energy, and others play a role, but no one seems to be in charge, leading to unchecked power and corruption. Second, we need a national UAP strategy that will promote transparency and help restore the American public's trust at a time when the public's trust is at an all-time low. This strategy should include a whole-of-government approach, including the academic and scientific communities, the private sector, and our international partners and allies. Third, Congress should create a protected environment so whistleblowers desperate to do the right thing can come forward without fear. As it currently stands, these whistleblowers suffer because of stigma, a code of silence, and concerns about retaliation. These whistleblowers should be encouraged to come forward in ways that protect them against any forms of retaliation. Policies and procedures should ensure that protection, and for those who refuse to cooperate, it is up to the members of this committee and the other lawmakers to wield their subpoena power against hostile witnesses and prevent additional government funding to those UAP efforts that remain hidden from congressional oversight. In closing, we as Americans have never been afraid of a challenge. In fact, we thrive on them, whether it's eradicating polio or going to the moon. We don't run from a challenge, we take it head on. To the incoming administration and Congress, I say to you, we need immediate public transparency, and this hearing is an important step on that journey. If we approach the UAP topic in the same way as we, as Americans, have met other challenges, we can restore our faith in our government institutions. Together, we can usher in a new era of accountable government and scientific discovery. I believe that we as Americans can handle the truth, and I also believe the world deserves the truth. Thank you, esteemed members of Congress, for your time today. It is profoundly appreciated by many.